Okay, we're ready, guys. Guys, you ready? Hello. Welcome to what we'll call week 1 of CS50DC. So we're calling it week 1 because obviously computers count in binary and they always start with 0. So last week was week 0. If you weren't able to attend week 0, but you still want to go and see what was covered, what we did, what we introduced, then please don't forget to go and subscribe to our YouTube channel, which is here. So if you just go to YouTube, oops, I've just lose the screen. If you just go to YouTube and type in CS50DC, it should come up. We've got the lectures on there from last week, and we've also got a few longs, we're calling them longs, and these are presentations that our teaching fellows have given in their A-level computer science lessons on a variety of different computer science or programming concepts. So again, please subscribe if you will, and feel free to just drop on those in case you miss anything. So last week we finished the lectures by looking at this fantastic piece of software from MIT called Scratch, and we introduced the problem set, the first problem you've got to go and solve as part of this course, as it were. And we had a nice workshop on Monday that went really well, and I was pleased to see that some of you have already got stuck into this. But what I thought we'd do is I thought we'd slow it down a little bit and just revisit what the actual problem set is about, why we're looking at Scratch, and more thoroughly just kind of do a little quick workshop on the things that you can do with Scratch. And like I said already, just in the workshop on Monday, I saw some great stuff being done. Murtaza and Ojan and Will said the same thing as well. There is some great stuff going on already. So you're already getting to grips with computational thinking, looking at a problem and applying computational programming concepts to solve it. But I just want to show you a few things that you can do just in case you weren't aware that these things existed. I just need to grab my sheet here. So I'm going to dive into Scratch, and hopefully if we've got some audio working here, which I think we have. Yep, super. I'm going to first of all introduce the interface in case you're not aware of the interface and what it is. So this is Scratch if you haven't seen it, if you haven't started the problem set yet. On the left hand side here we've got what we call the stage. So this is where basically the games that we're going to be building, as it were, this is where they will play. This is where you will see what you create. And on the stage at the minute, all we've got is a little cat. And that little cat is called a sprite. A sprite is each object that you can put on the stage. So you can have cats, you can create your own images if you want to on there. You can actually change the background of the stage as well. So you can put your objects in a scene, as it were. Here we've got the block palettes. And these are sort of like, instead of having you write textual programming, you can just drag these blocks onto your stage, as it were, or your sprites, as it were, and I'll show you that in a minute, to make them do things. But you don't actually drag them onto here. What you do is you drag them into this area called the script panel. And this is where we will build our scripts that make either the stage do something or our sprites do something. And again, I know some of us have played around with it, so we're going to start from very small to going to something that I haven't seen anybody in the workshops implement yet, called abstraction. So we're going to take it in a very 10-15 minute little session from knowing nothing about Scratch to just knowing that little bit more. So the way it works, like I said, these are my sprites here, and if you look down here at the bottom, if I click on the sprite, nothing seems to happen, but you need to know that this is the script palette for that sprite. And the reason I point that out is because if I had many sprites in here, of which I can do, then there will be a separate there'll be a separate script palette for each sprite. So if I click on the stage, for example, this now is the script palette for the stage. And I'm just going to start, because what you've got to do is you've got to think, well, what do I want to program? Do I want to make the sprite do something, or do I want to make the stage do something? Which sprite do I want to make do something? So I'm just going to make that cat, which is actually called Scratch. I'm going to make the cat do something. So I need to make sure that I'm on the sprite, and it's the script palette for that sprite. And I'm going to start by just making it do something very simple. Everything has to start with an event. We talked about this in the last lecture. Again, if you didn't see it, go and visit it on YouTube. Everything has to start with an event. And you'll figure out what a lot of these do, and we'll play around with a few of these as we go through this little workshop. I'm going to say, well, when the actual game starts, when the green flag is clicked, I want something to happen with this sprite. So just remember, all I'm doing at the minute is putting a set of instructions on that cat. And I'm saying when the game starts, I simply want you to say something. So again, it's a matter of looking around in the at the blocks palette here and figuring out, well, if I want it to say something, is that something to do with the looks? Is it something to do with the motion? And again, feel free to just go in and have a look, and oh, it has to do with the looks. You can see that I want it to say something here. So what I'm going to do is I'm going to make it say something for a certain amount of time. You notice I just drag these in and I attach them to any of the blocks that I've got in the script palette. Like that. And I'm just going to get it to say, hello world. And if you remember, I showed some, I don't think I've got access to this today, but I showed an interpretation of this hello world script in C, which had about 5 or 6 lines of code. And this is just going to do exactly the same thing here. I'm just going to get that sprite, when the green flag is clicked, to say hello world for 2 seconds. And this is actually a function. This little purple block that I've dragged on there is a function. It's saying do these things when the green flag is clicked. What are the things? Well, I want it to say hello world, and it's got some parameters. How long do you want to say it for? I want to say it for 2 seconds. So if we just see if this works, hopefully our sound will come out. In fact, we haven't attached sound. All it's actually going to do is say it. Yeah, it's just going to print out hello world. And now what I'll do is I'm going to actually make it say something. So to delete these blocks, I just drag them into the block palette. And now I actually want to attach sound because I actually want it to meow. So I'm going to get it to say meow. And again, I'm going to play it. That's not annoying at all. I haven't got cats. I haven't, but I've got friends that have got cats, and when they do purr or they do meow, they tend to do more than one. So I'm just going to drag a couple of meows on here, because I want it to do it 3 times. So I'm going to drag it, and I want it to meow, meow, meow. And I'm going to... Hang on a minute, there's a little bug in this. I've told it to meow 3 times. When the green flag is clicked, and I've just clicked the green flag, I want you to meow 3 times, and it's not doing it. Any reason, anyone know why? Why is it not doing it? I've clearly put the instructions to say meow 3 times. But why is it not doing it? Yeah?
Would it be doing all 3 at the same time?
That's absolutely right. That's exactly what it's doing. This is an event that says when the green flag is clicked, do these things. And it's doing all 3 of them at the same time. So they are meowing. There are 3 meows, as it were, but it's doing them all at the same time. So what I might want to do to improve that, I might want to change that and say, well, I want you to play a sound until it's done. When you give instructions to a computer, something that you have to learn very quickly is that they can't be ambiguous. You've got to be very specific about what you are telling the computer to do. It didn't know that I wanted them to play them one after the other. It didn't know that I wanted them to play one, wait till it had finished, then play the next one. I had to be very unambiguous with the instructions that I'm giving. So again, you can see there's a block here that says, now play me out until done, play me out until done, play me out until done, and now if I click the green flag, and again, even that's a little bit annoying. And so what I want to do is actually, I do want to do this, I want it to meow 3 times, but I'm actually going to make it wait. So if I go into this control block here, I can actually say, well, play that sound, and when it's done, wait for 1 second, and then I'm going to go back, and I'm going to say, and then do it again. So I'm going to say, play the sound again, wait till it's done. Go back into control. I'm going to go back into control. I'm going to say, play it 1 second. I'm going to go back to sound. I'm going to say, play the second. This seems quite repetitive. Go back into control. And I think I'll just leave it there. I don't want to wait another second because there's no point. And I'll play it now. Now, again, as you can see, when I was doing that, it wasn't an efficient way of doing this. I was copy and pasting. And that's like sort of like a trigger point when you're programming. If you ever catch yourself copy and pasting, stop. Because you're probably doing something wrong. And the reason you're probably doing something wrong, and this is not just when you're doing things in Scratch as it were, if you ever find yourself throughout the problem sets that we're going to introduce later on in this course, if you ever find yourself copying and pasting, stop. Because computers are great at doing repetition. They're great at doing things repetitively for us. And there's constructs that we can implement that will do something for us. Does anybody know what those constructs are? What method can I apply to this? How can I make it more efficient? Yes, Mohammed?
Use a loop.
I could use a loop because I can see a pattern. I can say, I'm saying, play this sound and wait for a second, play this sound and wait for a second. So I'm doing the same thing again and again. So what I can actually do is I can say, repeat 3 times that instruction. I'm not going to do it 10 times because that will be really annoying. So repeat 3 times that instruction. Now, it does exactly the same thing, but it's more efficient. It's a better idea. It's a better implementation of that program. Yeah. And this is the sort of thing that we need to be seeing from you. For any of you that have passed it through the Dr. Scratch website that I showed you last lesson, where it kind of analyzes your program, these are the sort of things it'll be looking for. Yeah. Have you used a loop when necessary? And again, it's basically, it's got rid of that redundancy. There's no need to repeat those instructions. Right, okay, so what I'm going to do now is, this is a little bit boring. Scratch isn't actually doing much, he's just meowing, he's just saying words, or I've got him playing sound. So I'm now going to play around with making him move. So I'm just going to dump all of this in here. I'm going to start with an event again, and I'm still going to do it so that when the program starts, when the green flag is clicked as it were, I'm going to say, right, I want you to forever do something. Now forever is this idea that, well, do something forever. Right, okay, well, let's see whether it can do this forever. I want you to move 10 steps forever. Now, as you can see, at some point it will stop because there's actual restrictions within this software that says, well, you're not going to go past this stage. But in theory, if I go and have a look at what's going on, if I try and drag this cat back, it's still moving until it meets the restrictions of this software, which is you can't keep going too far past the stage. But it is moving forever. And again, that's just a little bit boring, not very interesting. But what about if I was to do something like this, where I introduce something like called conditions that says, well, I want you to move forever 10 steps, but if, which is here, once you are moving 10 steps, if, and sensing is something I can use here to say if you're touching the edge, if I sense that you are, where are we, touching the edge of the screen, then what I want you to do is I want you to turn. I'm going to ask you to turn 180 degrees. Let's see what this does now if I put it back where it was. Now again, it seems a little buggy. I guess it shouldn't be flipping. Would anybody know how to resolve this issue that I've clearly got now? He is bouncing from edge to edge, but because I'm actually turning him 180 degrees, when he goes from one side to the other, he's actually turning upside down. And I don't want that. I just want him to face the other way. Would anybody know how to solve this? Has anybody got any ideas of what we might do here? Yeah, Anna?
You could try reflecting the scratch so it faces the other way when it touches the
I could try reflecting the scratch so that it faces the other way when it actually touches the side of the screen. Okay, so let's try looking at how we solve that problem. I'm just going to stop him when he gets to the middle. Okay, so he's facing the right way. Now, if I go into the sprite here, and I'm clicking on it, and nothing's changing, But if you notice above this blocks palette, I've also got these 3 tabs at the top. And one of them is costumes, here. And the costumes are, well, that individual sprite can have different states. It can have a different look to it. So what I might do, for example, is I create another costume like this. I've now got 2 costumes here. This one's called costume 1. This one's called costume 2. And I might try and rotate him like that. So in costume 1, he's facing this way. And in costume 2, he's facing that way. And so if I go back to my scripts, here, remove the turn and change the look instead so that when he's touching the edge, I'll still need to, in fact, you can spot what the problem might be here. I'm going to change the costume to 2. What might be a problem here? It's kind of like, well, instead of turning him, you've kind of solved this problem. You haven't turned him around, you've actually changed the costume, but where's the problem going to be? Here. Matthew?
You haven't told it to when it gets to that side to change it back.
Yeah, absolutely. So if I play this now, he's going to touch the edge, he's going to change the costume, but I haven't actually told him to go back the other way. So again, I could do this. I could keep that original motion and say turn 180 degrees and then switch the costumes. Oh, we can spoiler alert there. Let's put him back in the middle, and now he's all messed up. Oh gosh, now he's going all a little bit crazy. It's going all over the place. And that's because I actually turned him 180 degrees and I need to get him back to the center. But again, when you get these little books, this is why we hand out the rubber ducks as prizes for that rubber duck debugging. Get your little duck out, and if you haven't read the documentation for this, put the duck on your computer, explain to the duck what your program should be doing, and then go through it and say what it's actually doing, and you'll probably figure out what the solution is yourself. Again, well, I won't go over this one too much. But that has introduced this idea of costumes to you. If some of you haven't seen those, I didn't actually see any of those on Monday in the workshop. And it's also introduced this idea of, well, you're going to have to go and solve these problems. And this duck might help you do it. Okay, I'm going to move on, because I'm conscious of time and we've got to get through quite a few things here. The next thing that I want to introduce to you, if I just hit refresh here, is something called variables. And variables are very useful, a very useful concept that we use quite a lot. Not just in Scratch, but when we create other programs as well. So let's see what I'm going to do here. First of all, I'm going to go and make a variable. I'm going to call it counter. And you'll notice here when I create the variable, I can say, do I want this variable to be accessed by all sprites? Now in this example, I've only got 1. But I might have many sprites. And a variable is a place in memory where I can store a certain value. Yeah, that value might be a piece of text, it might be a number, but I can store a piece of a value in this place in memory, and then I can change it, because that's what a variable is. It's something that can keep changing. Now, if I say that I only want the sprite to be able to access this variable, then the only place where I can actually change it is in the script window for that sprite. Now, in this example, it doesn't really matter because I've only got 1. There's this concept of global variables, and by doing this, I'm going to set this as a global variable. I'm going to let anybody, any sprite, even the background, be able to change this variable if I want, because I've left it for all sprites. Press OK. Now I've got this variable called counter, and I'm going to start my program that says, right, set counter to 0. And then I'm going to do a control block that says forever looks say, and notice what I can do here now. I can get, as long as I press stop, I don't want to spoiler, I can say, instead of actually putting the parameter here of the word hello, I can actually drag this into this block. So I can say counter, we'll just set it for 1 second, and then I'm going to go back to my control and just wait a second like we did before so we can actually see this going on. And then if I press play, it's just going to say the counter 0 every time, but I want the cat to count. I want the cat to say 0, then I want it to wait, and then I want it to say 1, then I want it to wait, then I want it to say 2. So what could I do you think? What could I add to this block that will make that happen? So have a look. If we had a rubber duck, we'd say, okay, what I want to do is I want this scratch sprite to count for me. Okay, and what is it doing? Well, I'm saying I've got a counter, and I've set it to 0 because I want the cat to count from 0 up to 5, for example. I'm going to just let it keep going, actually. And I said forever, get the counter and get the sprite to say it. And then wait for 1 second, and then it's going to keep saying what counter is. And I set counter to 0 at the start, so it's just going to keep saying 0. So what do I need to do? What have I forgot to tell this program to do? And I just realized by telling the duck what I'm doing, or what I actually want to happen, is not the same. What do I need to do? Any ideas? Yeah, Robbie?
Counter equal to counter plus 1.
Good, I need to increase the counter. So if I go back to the data here where my variables can be changed, I've got these blocks here, and what I could do is, if I set the counter, that says, right, set it to this value. But if I say, change the counter, just like you said, I want to set the counter to the counter plus 1, and I put this in here. Now think about the forever loop. The forever loop only loops these 3 blocks. It doesn't go back up here and set it to 0 again. So now if I play this, it'll say 0, then it'll say 1, then it'll say 2. And this will just keep going forever, although that's a little bit of a white lie, because in the previous lectures we talked about that computers do not have infinite memory. Yeah, they have finite memory, which means that at some point we will run out of memory for these numbers to be printed. But in theory, if we left it going here for the rest of the session, we'd probably get up to about 1,000 or something like that. So, that's variables, that's how we can use those. The next thing I want to talk about and introduce you to is, I won't do the threading one actually. I'm going to start talking now about something called abstraction. Okay, and this is what I definitely didn't see anybody implement on Monday, and it is one of the criteria that when you pass your project through the Dr. Scratch website, it looks for abstraction. So first of all, we need to understand what abstraction is, and then how we might implement it in Scratch. Okay, so let's imagine that what I want to do, and I'm going to tell this to my little duck, what I want to do is I want to make Scratch cough. And I want to make him cough 3 times. Okay? So I'm going to do that. I know how to do that. That's quite easy because it's actually implementing all the things that we've done previously. Rather than him saying meow 3 times, I want him to say cough 3 times. Well, that doesn't seem too difficult. So I'm just going to create an event that says, well, when the flag is clicked, I'm going to say looks, say cough, C-O-U-G-H, and I'm going to say that for 1 second, and then I'm going to wait, and again, if I keep doing this, it's not going to be very efficient. I'm going to go back to looks, I'm going to sit and notice again, this is getting quite tedious, and so again what I might do is I might say, well, just use the loop, what we looked at earlier. So again, alright, I'm going to do that, I'm going to say forever. Oh, I won't say forever because I know I wanted to do it 3 times, so I'm going to use a repeat 3 times, say cough. Now, this is okay, but I don't really care about how this works. I'm looking at that and saying, okay, these 3 instructions here, the repeat, say cough for 1 second, wait 1 second, that's fine, that's okay. But it'd be cool if it'd be so good if MIT had just invented a block that says cough, and it does those things for me. And the thing is, we can actually do that. We can create our own blocks that says, when I drag the block that says cough under this green flag, do those 3 things. And that's the idea of abstraction. I don't really care how it's working. I just want it to cough. I just want it to do those things. So what I'm going to do now is I'm going to take this and I'm going to create my own block. Right, so I'm now going to create more blocks that MIT did not add. I'm going to create one, and I'm going to call it cough. Sorry. There it is. I'm going to call it cough. Press OK. Now I've got this block called cough here. And then what I'm going to do is I'm going to drag these instructions to cough. And then what I'm going to do is when the green flag is clicked, cough. So keep your eyes on this one. Well, really? Have I made it any more efficient? Well, no, because I still need all these blocks. But let's imagine that these blocks, I don't care how this works. So if I just put this all the way down here, so you can't see it, I don't care how it works. I just want Scratch to cough. And now all I have to do is when the green flag is clicked, cough. And let's just see this work. Cough, wait 1 second. Cough, wait 1 second. Cough. And this is a whole block that I just created that coughs. I can actually take it a step further. And I can actually do this. Add an extension. I'm sorry. I can't see the screen very well. Make a block. Options. Okay, so what I'm going to do now, I'm going to create another one called sneeze. And I'm going to add an input value to it. And I'm going to press OK. Now what I'm going to do here is I'm going to create this sneeze block. I'm going to copy this code here, put it under here, just say sneeze. And then in here, I'm going to go to more blocks. Sneeze. Blah. Okay. And now have a look how this is slightly different. What I'm going to do now, when I said cough before, I was restricted to how many times I could cough by the actual function here. I had to type how many times here I wanted it to cough. But now, because I've added this new parameter here, when I drag the sneeze function to start, I now have options to actually choose how many times I want it to sneeze. Yeah, now this isn't actually going to work at the minute because what I haven't done is I haven't actually received those values inside the function. So I'm going to have to do that. I'm going to sneeze 3 times, and I'm going to pass that to there. And now I'm going to say sneeze 3. This is going to do what sneeze is done. The 3 is going to be received by this variable, this parameter called number 1, and then it's going to say repeat. Whatever is in number 1, which is 3, it's going to do this 3 times. And if I want to do it 4 times, or if I want to do it 8 times, I just change the number in here, and it will now do it 8 times. And so these are sort of other methods that you can implement into your Scratch projects. And it's something we're actually looking for when you submit your project. So if you can abstract something, then try and do that. Okay? So that's my little workshop.
Hit your screen size. Actually,
Boy,
how big
why-
my phone is. That's it. I challenge you to a code war.
Guys, we've got a code war. Let's do this. Right, there's only one way to settle an argument. These two, they're going to be doing the code wars. We're going to have to challenge them to settle this argument that they've clearly been having. I don't know what it's about. We're going to set them a code war. We're going to give them 5 challenges in Scratch, and they're going to have to actually solve these challenges to settle this argument. If you want to compete against these, then please feel free. Boys, here's your first challenge. In Scratch, I would like you to create a program where the cat follows your mouse. Off you go.
There's no.
Ah.
Jesus.
Well,
Done.
well, he's won that fight. That's 1-0 to Batman.
Didn't even open.
1-0 to Batman. Next one. Make your cat move left to right. It's your fault. You should have logged on faster, Matalza. Make your cat move left to right. Off you go.
Left to right. Okay.
Yep.
Right.
I think Oja's going to win this fight. There you go.
I'm not sure actually. That's what I did. Am Am I doing exactly what
You're
you
definitely going to win this fight because it's not working. Oh, he's off. He's off. I want your cat to move from left to right like we did at the start. Make it go from right to left, right to left. Who do you think's going to win this one?
Does it have
Superman
to
or Batman?
reflect?
I think Superman's got this one.
How do I change? How do I rotate this back? To
Well, you've got to figure that out, Batman.
If I...
Oh, maybe not. Maybe Batman, you've got time to come back.
There we go. Oh crap. Where's the...
Shows that they haven't been listening to this workshop. We did this one
Right.
just moments ago, boys.
We make
Just
it
moments ago. There we go. Well done. Well done, Superman.
Alright,
Next one.
Batman, let me show you how it's done.
Oh, we've got another person stepping in. He's out of there. Will. Get him on. Next one.
Upside down.
Create a variable that increases by 1 every second. Create a variable that increases by 1 every second. Has anybody got any other challenges? Things they'd like to do? Things that they've done in their projects and you'd like to see these two implement? Anything? No?
Make the sprite bounce off the walls at random angles.
Love it. We're doing that. So we got. Let's see your solution to this one then, Batman. Is it working?
Yes.
Oh, he's got it working. Well done. Mataza, Will, or Batman, Superman, your next challenge is make a sprite bounce off the edges in different directions so that it's bouncing around the stage. Would anyone like to come and compete? Yeah, let's go. Right, whoever loses this one, you've got a new challenger. So if you lose, you're out. Winner stays on. Oh, we've got spinning motion, but he's not bouncing. Oh. Oh, I'm not going to pass that one. That's still a fail, Batman. Oh, Superman.
Oh.
I think that counts. Superman's done this one. Batman, get off. Give it to Muhammad. Let's go. Next challenge. When you press the space... I'll speak slowly. When you press the space bar, your sprite must jump and land back on the ground. Let's go. If you hit refresh, Batman, you'll get a new screen. Or F5 it. Reload.
Oh no.
Go, 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 go. Anybody else want a challenge? No?
Can I re-challenge?
You can re-challenge, Ocean. You can re-challenge. So on this one, we've got when the space bar is pressed, I want the sprite to jump. I want it to increase its y-axis and then fall back down to the ground. This is a tricky one. This is something that I know some of you have wanted to do, and I know some of you have actually implemented. Looking good, boys. Looking good. Oh. Oh, that's not a bad effort, Mataza. What have you done? I want it to go straight up.
Yeah.
Are we there?
Getting there.
He's done it. Superman has done it. Hammond, I'm afraid you're off. Swap your cape. Ocean, you're on. You ready?
Yeah.
I want 2 sprites. I want one to chase the other. Automatically. Go. Oh, the cape's off. The cape is off. I want 2 sprites. I want one to chase the other.
Apple chasing the cat.
Let this be known to you that if you ever want to settle an argument, don't fight. Just code it out. Code it out. Get on your computers. Don't put on the boxing gloves. Get your cape off and code it out. Who do you think's going to win? Ocean or Mataza? Mataza easily. Oh, I said automatically. You're dragging him round.
What, this guy? Do you want this
No,
guy to move
I
as
want
well?
them. I want him to be running away.
Okay.
I just get them both to follow the line.
Oh, that's a good start. You've got them both going, Ocean.
What?
Oh,
You two
Anybody got any other challenges, things that they wanted to implement that they haven't been able to do? Anything?
Make stuff fall from the sky.
Say that again, sorry?
Make stuff fall from the
Does that count?
I think that's working.
Why is the thing?
Do we let him win?
Yeah.
Yeah, we let him win. Matars, you're off. You're off. Will, Mohammed, who's stepping in? Let's go. Next one. You ready, Ocean? You can make a start. Make things randomly drop from the top of the stage to the bottom. Object. Same object if you want, but it's got to be more than one object. Yeah? So it can be the same object dropping multiple times, or several sprites dropping from random points, the top of the stage to the bottom. There's rubber ducks there if you need them. I've lost one. Left, right. Talk to him. Talk to him if you're stuck. You can talk to that if you're stuck.
That's one.
Thank you for volunteering. Anybody else want to win a rubber duck? Anyone want to come down and do a challenge? Oh no, let's go. You're next up. Anybody want to shout out a challenge? These are all things that you could steal off them for your own problem sets. If you want to know how to do something, anybody?
Do the same thing with the falling, except Spot will be acting with gravity.
Ooh, you've got time to think about it.
I think Ojun has some advantage on this one.
See that? Harry, isn't it?
Yeah.
Yeah. Take a look at Harry's little project if you've got 5 minutes. What he did in what, 20 minutes?
Yeah.
What he's done in 20 minutes is pretty cool. He's created a little keep you uppy game. Very good. And have you seen the problem set, Harry? Harry, have you actually seen the problem set? Have you seen the
You need to make it
the
follow
criteria
you.
of the problem set?
Yeah, I'll change the
I
Wi-Fi.
haven't had a proper look.
We're going to touch on that in just a minute. Okay. Are we nearly there, boys?
Almost.
So Adam, your challenge where you step on is to do the same thing so you can leave this code on. Yeah? But you must implement gravity. Good start, Urgent. Good start.
Try it.
Remember, to fall means to come down. Oh, he's talking to the duck. Oh, it's on. It's on.
Dude, that's touching the edge right now, that's why.
Oh,
thanks.
I'm just gonna be.
Oh yeah, this is.
The ducks don't talk back to Tarzan. The ducks don't. Will,
Yeah.
are you just clicking?
Pardon?
Have you got any code yet?
Oh yeah, I do somewhere.
It looks pretty.
There we go.
Oh, there you go. Oh? Well, something's falling. I don't know who that is.
Do I make both? Oh.
Yeah, I want him to go off the screen then. Oh, I want him to. Yeah, I want them both to do it. Randomly, they dropping from random points.
Oh, from random points.
Yeah, I want them to randomly drop from different points on the screen. Has anyone got this in their actual problem set solution? Has anyone got? Yeah, and did you implement it?
Yeah.
Oh. Oh.
Yeah, I got really stuff fall from the sky.
I think it's because you've not got the capes on. Personally. You watch Will now. Your chances have increased by tenfold, Will. I'm going to give you another minute, and then Arnav's coming in. Arnav's coming on to just speak to the duck, Will.
It's not working.
More constructive, Will. Oh,
Oh.
hello.
No.
Hello. I'm not appreciating the lack of randomness in where it's dropping from. It seems to be a set X and Y there, both of you. Oh, what's that? Pick it. Ah, we've got a random function in there, have we? So pick random.
Where did it just go?
You've got 1 minute left. Make sure you're checking out one of their code. I'm actually thinking Ocean's the closest at the minute. Sorry, Will.
Oh, you just.
Have you noticed that you can drag some of the blocks into other sprites and it will duplicate them? Yeah, so that's going to save you some time. Hello. Why is only one of them working? Is it because again it's touching the edge or? When we say implementing gravity, how do you expecting this to look, Harry?
Well, I'm expecting to see 9.81 meters per second squared.
But are you saying when it falls it's going to hit the floor and bounce back? And,
Yeah, then let's have some of that, but let's also have
Increasing speed as well.
yeah, let's
Yeah,
have
that.
acceleration towards the
I
ground.
like it. Oh, we are there. Hang on. Are they going?
What?
I'm happy with that. That's good. That's good. That's good. Right, stay there, Ocean. Will. Anna, let's go. Right, do you understand what we want with the
What do I need to do?
gravitational pull? We want to increase in speed as it's falling towards the ground, and then we'd also like a bit of bounce.
Oh, God.
Who doesn't like a bit of bounce?
Did you just delete all the code?
Right, whilst these guys are still warming it up, problem set. If you haven't had a look at it yet, we have posted a link on the YouTube channel, yeah, from the last lecture to the problem set. The problem set has just got 5 pieces of criteria that it's got to meet. For example, it's got to have, I think it's at least 2 sprites, it's got to have certain things going on. So you've just got to meet that basic criteria. Our deadline for this problem set is next Tuesday. You're going to have to submit it next Tuesday. We're going to email everybody of how you do that. It'll just be a matter of making sure it's, keep going, making sure it's on the Scratch website so that myself, Mataza and Ocean, and also probably Will and Mohammed who are coming on board, can actually take a look at them and mark them. Yeah? Again, we will be using the Scratch Doctor website as our starting point. Yeah, we are looking for masters. What I mean by that is you run it through there, it will tell you whether your Scratch project or whether you are at master level. So keep plugging it in through there to see whether you are. If you're not, take a look at the areas where you're weak. It might be abstraction, which we've talked about today, and you can implement that. Is that okay? Okay, boys, I'm sorry, but it's come to an end. Arna, you feel free to take a duck. Feel free to stay if you like. That was CS50DC Week 1, Lecture 1. Thursday session tomorrow is going to be a workshop. We've got D1. We've booked that out. It's a workshop. We're all going to be there and help you get your projects finished. All right? Thanks for coming, guys. Take care.